friends, we are here to see the solved questions of fundamentals of electrical circuit, fourth edition by Alexander. Here is the question of chapter 3, some questions of chapter 3. Now let's see the solution. Here the first question is find I1, I2 and I3 for the given circuit. Here is the given circuit. We have to find I1, I2 and I3. There are three loops in this circuit. One is first loop is this, second loop is this, and the third loop is this. Now let's see the solution. As you can see here, three loops. This is the first loop, this is the second loop, and this is the third loop. Let the current in the first loop be I1, current in the second loop be I2, and the current in the third loop be I3. So for writing the equation for loop 1, you can write 120, here is the 120 plus 30 plus 10, 40 I1 minus 10, 10, this one 10, and the circuit in this loop, current I2 is going, so minus 10 I2 which is equal to 0. So after solving this, you will get this equation minus 12 equal to 4 I1 minus I3. Let it do equation 1. Now for loop 2, here is the loop 2. Similarly, you can write the equation for the loop 2. 50 I2 minus 10 I1 minus I3 equal to 0, which will give you minus I1 plus 5 I2 minus I3 equal to 0. Let it be equation 2. Similarly, for the loop 3, as you can see, this is the loop 3, this is the loop 3. So you just write the equation for loop 3. Minus 120 minus 10 I2 plus 40 I3 equal to 0, which will give you 12 equal to minus I2 plus 4 I3. Let it be equation 3. Solving 1, 2 and 3, we get I1 equal to minus 3 ampere, I2 equal to 0 ampere, I3 equal to 3 ampere. Hence, you will get the value of I1, I2 and I3. Now, let's see the other question. Here is the second question of exercise 3.76. Here we have to find use nodal analysis to determine V1, V2 and V3 in the circuit shown. As you can see, this is the circuit. We have to find V1, V2 and V3. Now let's solve. Let's see the solution. At node 1, as you can see, this is the node 1, this is the node 2 and this is the node 3. Writing the equation at node 1, this is the node 1. 2 equal to 2V1 plus V1 minus V2 plus V1 minus V3 into 4 plus 3 I0. 3 I0. This is the node 1, so you will write the equation at node 1. Here I0 equal to 4V2. Since here current is going in this is I0 and here the voltage is V2, so I0 is equal to 4V2. Hence, after solving these two, you will get this equation. 2 equal to 7V1 plus 11V2 minus 4V3. Let it be equation first. Now at node 2, you just see this is the node 2. After writing the equation at node 2, you will get V1 minus V2 equal to 4V2 plus V2 minus V3, which will give you 0 equal to minus V1 plus 6V2 minus V3. Let it be equation 2. Now at node 3, this is the node 3, this is the node 3, so you just see 2V3 equal to 4 plus V2 minus V3 plus 12V2 plus 4 V1 minus V3, which will give you minus 4 equal to 4V1 plus 13V2 minus 7V3. Let it be equation 3. Here there are 3 equations, so it is easy for getting V1, V2, V3. Let's use the determinant form to get the V1, V2 and V3. Now you can write in matrix form, you can write all the 3 equations like this. As you can see here, 7, 1, 4, 11, minus 6, 13. And these 3 equations 1, 2 and 3 you can write in this format, in the form of matrix form. 11 minus 6 13 minus 4 1 7 v1 v2 v3 2 0 minus 4. After this you will have to find delta, which is equal to determinant of 7 1 4 11 minus 6 13 minus 4 1 minus 7, which is equal to 176. Similarly you will get delta 1, which is equal to 110. Now similarly you just find delta 2, which will equal to 66. Delta 3, by using the determinants you just find delta 3 also, you will get 286. After that you have to find v1 v2 v3. So v1 is equal to delta 1 by delta, which is equal to 110 by 176, which is equal to 0.625 volt. Similarly you have to find v2, which is equal to delta 2 by v, which is equal to 66 by 176, which is equal to 0.375 volt. Similarly v3 is equal to delta 3 by delta, which is equal to 286 by 176, which is equal to 1.625 volt. Hence you will get v1 v2 and v3 as v1 equal to 625 millivolt, v2 equal to 375 microvolt, and v3 equal to 1625 millivolt. Now here is the third question. Using nodal analysis, find V0 and I0 in the given circuit. Here is the given circuit. In this I0 current is going, and here the V0. We have to find V0 and I0. So let's see the solution for this question. As you can see, this is the node 1 and this is the node 2. So writing the equation at node 1, V1 minus V2, V1 this is V1 minus V2 this is V2 divided by 40, this is 40 ohm, so divided by 40, which is equal to 100 minus V1 divided by 10 plus 4 V0 minus V1 divided by 20. Let it be equation 1. What? V0 equal to 120 plus V2. As you can see, V0, here is the V0. V0 equal to 120 plus V2. V0, here is the V0. V0 equal to 120 plus V2. Here is the V2. So after solving these two equations, you will get 7V1 minus 9V0 equal to 280. Let it be equation 2. Now at node 2, this is the node 2. Again you just write the equation at node 2. I0 plus 2I0, which is equal to V0 minus 0 divided by 80, which will give you 3V1 equal to 120 minus V0 by 40 equal to V0 by 80, or you will get the equation like this: 6V1 minus 7V0 is equal to minus 720. Let it be equation 3. After solving the equation 2 and 3, you will get by using the determinants, you just solve the equation 2 and 3 by using the determinants, and you will get V1 and V0, which is equal to your solution. Now for finding V1 and V2, use delta. By using determinant, you can find the value of delta, which is equal to 5. Similarly, you just find delta 1, which is equal to minus 8840, delta 2, which is equal to minus 6720. Hence you just get the value V1 equal to delta 1 by delta, which is, here is the delta 1, this is the delta 1, and this is delta. So for finding V1 you just divide delta 1 by delta, which is equal to minus 1688 volt. Similarly, for finding V0, you just divide delta 2 by delta, which is equal to minus 1344 volt. Hence you just find I0 value. After putting the value of V0 in this equation, you will get I0 value. Hence you get the value of V1, V0 and I0. That's all. Now here is the fourth question. For the given circuit, find V1, V2 and V3 using nodal analysis. Here is the given circuit. There are 3 nodes: 1, node 1, node 2 and node 3. Node 1 and node 2 form a super node. As you can see, node 1, node 2. There is a current source between node 1 and node 2. So it will form a super node. Similarly, there is a current source and there is a voltage source between node 1 and node 3. This is the node 1 and this is the node 3. There is a voltage source also. So it will also form a super node. So node 1 and 2 form a super node. So do node 1 and 3. Hence, as it is a super node, so after writing the equation at super node, you will get v1y4 plus v2y1 plus v3y4 which is equal to 0. Which will give you v1 plus 4v2 plus v3 which is equal to 0. Let it be equation 1. Now let's see. Between node 1 and 3, this is the node 1 and this is the node 3. You just write the equation v1 minus plus 12 minus v3 minus v1 plus 12 plus v3 equal to 0. So after solving this, you will get v3 equal to v1 minus 12. Let it be equation 2. Similarly, between node 1 and 2, here is the node 1 and 2. Here is the node 2. You just write the equation from here to here. So minus of v1 is equal to v2 plus 2i. Let it be equation 3. But I is equal to v3 by 4. As you can see here, I current is flowing this and here the voltage is v3. So v equal to IR. So I equal to v3 by r. Here r is the 4. So I is equal to v3 by 4. I is equal to v3 by 4. Combining equation 3 and this I equal to v3 by 4, you will get v2 equal to 6 plus v1 by 2. Let it be equation 4. Solving equation 1, 2 and 4 will give you v1 is equal to minus 3 volt, v2 equal to 4.5 volt, v3 equal to minus 15 volt. In this way, you can solve v1, v2 and v3 by using nodal analysis. That's all. Thank you.